I can see it. Anybody
Perfect.
else? Yep. Have a couple
Okay,
of more.
sounds good. I think we will start, and I will try to target so that we can have at least 20 minutes for some question and answers at the end of the presentation. So, without any further ado, today we are going to talk about gas lift systems in subsea and deepwater applications. Um, One thing which I want to mention is that this is primarily focused on the gas lift systems, how do they operate and how they help us in extracting hydrocarbons from the subsurface, uh, with some considerations about why this is considered one of the most reliable methods when we are considering offshore production or subsea applications, uh, whether they are offshore Gulf of Mexico, offshore Atlantic, or offshore West Africa, or in the North Sea, where most of the subsea fields are situated. So the agenda is that we will quickly start with a brief history of on the gas lift, how it started gaining traction in the world of artificial lift as well as production engineering. What are the loading and unloading sequence of a well, typical gas lift equipment, mechanics, uh, and finally we will touch a little bit on the application engineering and to kind of determine how the whole thing operates and what kind of considerations we need to have when we are designing this system. So, gas lift is a method of artificial lift in which essentially what happens is that high pressure gas is injected from the surface through the space between, let me change the pointer option. So the high pressure gas is actually injected from the surface. The gas actually travels through the space between casing and tubing. So this black space is the space between casing and tubing. This is called annulus. The technical name for this space is annulus. So the gas travels through this, and when it travels through this, it goes through a gas lift valve where it will enter the tubing. Once it enters the tubing, it will mix with the fluid that is in the tubing. Once it mixes with the fluid, it reduces the fluid gradient or the fluid pressure. And as it starts doing that, gas being lighter starts flowing towards the top. Um, and with that, it lightens up the fluid column in the tubing. And once it lightens up the fluid columns in the tubing, more fluid will start coming inside the tubing, and then it will start going up on the surface. So essentially, the principle of the production is based on reducing the fluid density in the wellbore to lighten the hydrostatic column, as well as reducing the back pressure on the formation. As you start reducing the back pressure of the formation will start naturally. In this simplistic gas lift system, you will see one gas lift station over here, and there is one at the top and one at the bottom. This is a very simplistic representation of the gas lift system. In the deep sea and deep water applications, we can have 5 to 6 stations in a well. So this is
Hassaan, just a quick question. How much pressure is actually created in this?
so usually our injection pressure is between 2,000 and 2,500 psi. For deep water applications, their pressure can go up to 5,000 psi.
Wow.
Injection pressure.
Wow.
So what essentially, this is just a top level view of the whole system with whatever equipment is required on the surface. The equipment that is primary equipment that is required on the surface is your separators, your gas compressors. So if you're injecting high pressure gas, you would need a surface gas compressor. So this is usually located on a surface platform. Now with the change in technology or the advancements in technology, subsea gas compression is becoming a thing of reality as well. Although they are still in a very early stages, there are very few wells that are using subsea gas compression, but essentially they can put a gas compressor on the seabed, and that gas compressor can be used for injecting high pressure gas um, into the annulus. Essentially, when the gas along with the fluid is produced, it goes to the gas separator, where the fluid will go into the stock tank, while the gas can be recycled for use by the gas compression. Now, on the downhole side, we have two major components of the gas lift system. It's a very simplistic system. That is the beauty of it. And the two major components of that gas lift system is what we call a SPM, side pocket mandrel, or gas lift mandrel, and a GL valve or a gas lift valve. So gas lift valve is essentially installed inside the gas lift mandrel. Gas lift mandrel is part of the tubing, so it will have thread at the top, thread at the bottom. We are going to talk a little bit more in the construction of gas lift mandrel because there is more that goes in the construction of a gas lift mandrel and the design features, as well as the gas lift valve, where gas lift valve can be retrieved. It is a retrievable component. So once the gas lift mandrels are deployed in the downhole, we can actually send an intervention tool down through a slick line or a wireline rig or a wireline unit, and we can actually pull this valve for maintenance or changeover. So gas lift was primarily invented by Camco in early 1900s. It started gaining a lot of traction in US land. That's where primarily the first gas lift valves were deployed. But over the period of time, this has gained traction all over the globe. Camco was the inventor of the gas lift systems and was a pioneer of the gas lift systems until it was bought by Schlumberger in 1999. So gas lift valve kickoff. This is a typical onshore well with different, at least over here, you can see 5 gas lift systems. And what happens is that usually if the well is full of fluid and it's not flowing naturally, that means all the way to the surface or to a certain point in the tubing, there will be a fluid. And that fluid is exerting so much back pressure on the formation that the formation is not flowing at all because of all that fluid gradient. Imagine if you have 1,000 or 2,000 meters of a well and that is full with fluid, that fluid is exerting so much weight that your oil from the formation will never get, or it will have a lot of impediment getting into the tubing. So the first thing that we do is kick off, and usually we kick off or unloading of the well are both used interchangeably. And what we do is that unloading of the well is usually one of the most critical phases of the production engineering. The reason for that is that we have to do it in a gradual manner while taking into consideration that certain parameters are met, because if we don't do that, it can actually damage the formation. So usually the unloading of the well is usually done at
Hassaan Ali, I didn't quite catch that sentence. If it doesn't happen correctly, what happens?
it can damage the formation.
Oh, got it.
Yeah. And usually there is a certain recommendation that we do it at the rate of 1 to 2 barrels per minute with a gradual increase of 50 to 100 psi per 10 minutes. Usually we have a production choke at the surface, which we will optimize. We will select certain choke sizes, and then we will start unloading the well. What actually happens is that you will start injecting the gas, and you will start injecting the gas through the gas lift valve, and then you will start lightening up that fluid column, and then you will start unloading the well. So optimizing gas injection rate, sometimes it depends upon your fluid chemistry as well. How, if it's a light oil, if it's a heavy oil, if medium oil, as well as your tubing as well. How big of a tubing you have. Sometimes for a bigger tubing, you need to have certain considerations. But what you try to do is that you will try to inject that gas at a certain rate and start getting that fluid flowing through the tubing onto the surface. So, so unloading valves, there are 2 types of valves, and I will use these terminologies interchangeably. There are what we call unloading valves, and there are type of valves which are called operating valves. Unloading valves are also called production pressure operated valves, PPOs, or injection pressure operated valves. We are going to discuss them and their construction in coming slides. But essentially, when you are unloading a valve, That means the well is not producing yet. It is just full with fluid, but you are not producing it yet. You need to remove all that fluid so that formation can actually inject its fluid into the tubing. And that fluid that is in the tubing can be the drilling fluid, it can be mud, it can be water, it can be saline liquid, it can be a mixture of these combined with the hydrocarbons. So you don't desire that liquid. It's an undesirable liquid. You need to remove it from the tubing first, and to remove it from the tubing, you need unloading valves in the gaslift method. Now, unloading valves are required only in the unloading phase. That means once the unloading is done, you need to remove those valves and you need to deploy your operating valve. So one of the characteristics of the unloading valve is that it opens only when the annulus and tubing pressures are high enough to overcome the valve set pressure. So the valve is actually set either through a spring or through a nitrogen charged dome, that it will not open until certain annulus and tubing pressures are met. That is one of the considerations, and I will show you how we determine that pressure in the coming slide. But one takeaway from this slide is that the unloading valve is usually closed, and it operates only when certain pressures in the annulus and tubing are met. There are two types of gaslift systems, and this is a very simplistic kind of a concept to comprehend. There is one type of gaslift wells which are called continuous flow. That means you need to continuously inject gas for it to flow. And there are intermittent wells. Intermittent wells, the difference between the two is intermittent wells are primarily onshore wells, very mature, old wells which have depleted over the period of time, does not have a lot of fluid in the formation. So the formation, you cannot inject the gas continuously to make it produce. You will have to inject the gas, wait for a certain period of time, and then let it flow, and then close it again. So the continuous flow gas flow wells are primarily the wells which are, you just need to assist them a little bit so that they can flow naturally. They have enough pressure in the well itself or in the formation itself to push the fluid onto the surface. You just need to assist a little bit in the initial phases, primarily for kicking off and for unloading of the fluid. Once that is done, it will start flowing naturally. And this is an example of a continuous lifted well. Essentially, what happens is that this is an example of how you determine at what depth and at what pressure you need to operate your gas lift valve. What happens is that as you will start injecting gas into the formation or into the tubing or into the annulus, and it will start mixing with the fluid in the tubing, your tubing pressure gradient will start reducing. There is no production yet, but your tubing pressure gradient is reducing. And it will reduce to a point where your gas lift valve will open. Now, with that being done, your casing pressure will start increasing as well, because it will start increasing and increasing and increasing to a point where it will overcome the set point of the gas lift valve. When it will overcome the set point of the gas lift valve, something drastic happens. Your fluid pressure gradient drops drastically, while your casing pressure will start increasing. So that is the point where the intersection point is the point where it will overcome the set point of the gas lift. And then you would know that you are now gas lift in the valve. The other telltale signs is that you will start seeing fluid on the surface. So in the continuous flow, you will keep on injecting gas and the well will keep on flowing. But in the intermittent flow, what happens is that all your valves are closed, including your operating valve that is at the very deepest injection point in the well is closed. This is just before the gas injection has started. Now your operating valve will open while all the valves which are above the operating valves are closed. You will start injecting gas. You will open your surface controller. You will start injecting gas. And that gas, since all the other valves are closed, it will go to the deepest point in the well. Once it goes to the deepest point in the well, it will mix with the fluid. This fluid was already there. If you see before the gas injection, there was some fluid already there. What will happen is that it will start pushing that fluid column to the surface. Once it starts pushing the fluid column to the surface, it will drop the level of fluid in the well, and all the fluid that was accumulated in the tubing will go to the separator. Now, when the tubing fluid level will fall below the operating valve, what will happen is that the operating valve will close. When the operating valve will close, the surface controller will also close. And then it will wait for the fluid to come back up again. And once it comes back up again, it will start following the same cycle again and again. So it is intermittent because it is not continuously lifting. It will wait for the fluid gradient or the fluid level to build up. And once it builds up to a certain point, the surface controller will open, injection gas will come into the deepest point in the well, mix it with the fluid, take it to the surface, and the surface controller will flow. So that is what we call intermittent gas lift system. Now, coming back to the continuous gas lift systems, there are different ways we can configure our completion or our downhole components. The most simplistic is what we call a single zone gas lift installation. That means you have different stations over here, you have a packer over here. The fluid will come from, so the packer is kind of isolating this fluid from going into the space between the tubing and the casing or endurance. So the packer is essentially a barrier component. The fluid will come, enter the tubing, go through the gas lift valve. We will inject from the top. The gas will come, mix with the fluid over here, take it to the surface. This is called a single zone gas lift installation. The dual zone gas lift installation is essentially two tubing strings in a casing, in a single casing, and they have two packers. And essentially what we are trying to do is that we are trying to produce from two zones. And you don't want these two zones to commingle for different reasons. It could be because of the pressure differential. It could be because of you want to keep the production fluids or production stream separate from one zone to another. It could be the reason that one zone is producing too much water and you want to isolate that zone, and different other reasons. So what actually happens is that you will have packer between two zones. You will produce this gas lift installation that is part of the one tubing will produce from this zone. Then there is a packer, and then from this zone, this is the completion that will produce. This is what we call a dual string gas lift installation. Then there is another type.
Hassaan Ali, did you see the messages to speak a little louder?
I will try. Okay, thank you. So the other one is called a chemical injection system. Chemical injection system is different from a single zone gas lift installation by means of that there is a special type of mandrel with a special type of valve, which is called a chemical injection mandrel. Essentially, we need this kind of installation when there is too much paraffin in the production fluid, there is too much scaling in the tubing. So we want to inject certain production chemicals to get rid of that. In that case, we will deploy one station with a chemical injection mandrel and a chemical injection valve. The chemical is injected through a very small tubing, usually 1.25 inch, 3/4, or 1 inch tubing. It is run from the surface all the way to the down hole to the chemical injection mandrel. And the chemical will be injected through this tubing, while rest of the completion is a typical completion like a single zone gas lift installation. And there is one more, which is not so common actually. This is called a macaroni installation. In macaroni installation, you have a dual string as well. You will have one string, which you can see right over here with the gas lift mandrels and gas lift valves. And there is another string, which is right over here. This is done because of one main reason. That one main reason is that there is one formation that would require gas lift assistance for it to flow, while the other formation does not. So what happens is that one formation is just completed with a single tubing, while the other formation will be finished or completed with the gas lift valves, mandrels, and tubing, essentially helping one formation to flow naturally, while the other formation will be artificially assisted. We are going to talk a little bit about the gas lift system or gas lift station, what we call it. As I mentioned earlier, there's this carrier which is part of the completion called a gas lift mandrel. This gas lift mandrel acts as a housing for the gas lift valve. This gas lift valve is installed in what we call a pocket of the gas lift mandrel. And then on top of the gas lift valve, there's a latch, and the latch is there to securely hold it in position, because with the pressure differentials and pressure, different type of annulus and tubing pressures, they can result in the movement of the gas lift valves. And we do not want a lot of movement, because too much movement can actually push this valve out of this pocket. So we want some sort of a device to securely latch into place. Gas lift latch is essentially that device. Talking a bit about the side pocket mandrels. Side pocket mandrels differ in construction, depending upon what kind of pressures you are dealing with, what is your tubing metallurgy, and what are the different types of formation fluids it will encounter. In the presence of paraffins, in the presence of H2S, in the presence of CO2, you will need a different type of metallurgy. Usually, API 19, G1, and G2 are the two API standards that will determine the construction of gas lift mandrel and gas lift valve. So the API actually dictates how we manufacture these equipment and what are the industry standards we need to follow. So usually for the onshore installations, we use the pocket of the gas lift mandrel is either 1-inch pocket. That means a 1-inch nominal dia valve will go inside this pocket, or 1.5-inch valve pocket. For the deep sea and subsea applications, we use a special type of valve which has a nominal dia of 1.75 inches. That is called an extreme lift valve. It is usually not determined by the API grade, and usually it is proprietary to certain companies. For deep sea and subsea applications, there are certain considerations. For example, we try to use, just because of the high pressures, we try to use premium metallurgy. That means we would use nickel alloys, either nickel alloy 925, nickel alloy 718, or stainless steel with high chrome components. For onshore applications, we use carbon steel or 410SS or 41013 chrome. Just because in onshore applications, we do not have a lot of pressure. Usually most of the fields are very depleted. There are two types of cross-sectional configurations. One which you see over here is called round configuration, in which the pressure is uniformly distributed. There is another one which is called oval configuration, in which the pressure is non-uniformly distributed. Primarily, the round mandrels are used for the round cross-section mandrels are used for the subsea, deep sea applications, the high pressure applications, and high temperature applications, while the oval mandrels are used more for the onshore applications. Some of the features in the side pocket mandrel are what we call orienting sleeve. There is another one which is called tool discriminator, and the pocket as well. We have discussed about the pocket. It is essentially a housing for the gas lift valve. Now for orienting sleeves, this is a feature that is machined inside the mandrel, gas lift mandrel, and it acts like a locating feature for the intervention tool. As I mentioned earlier in my presentation, that there is an intervention tool that can be used for pulling these valves or deploying new valves. For that tool to work and orientate in the pocket, because the pocket is, if you can see, it is always at 12 o'clock to the main bore of the mandrel. For that intervention tool to come orientate, pull, and push the valve, it needs to locate itself inside the mandrel. For that, it needs this orienting sleeve. Then there is a forged pocket or tool discriminator over here. The tool discriminator is to assist that intervention tool and guide it to the entrance of the pocket. This, um, this tool discriminator is usually located ahead of the pocket. It will help the tool to orientate and then guide it to the entrance of the pocket. Once the tool goes to the entrance of the pocket, then it can actually push and pull down. For the subsea and deep sea applications, there are other considerations as well. There is for the subsea wells, there is a lot of monitoring in terms of production, in terms of temperatures, in terms of pressures. Usually for that, we have to run cables all the way from the top to the bottom of the well. These cables actually have to pass through to the tubing as well as the gas lift mandrel to protect that cable. This is usually they are in the form of what we call a flat pack. So it's like all of the cables bundled in an armor, and that armor has to be, or that cable has to be secured around the gas lift valve. So for subsea and deep sea applications, we have these special channels that are machined inside the gas lift mandrel, and so that we can actually deploy the cable through that channel, and then it is secured through these lock screws and lock plates. Talking a bit about the latch. So the latch chemistry, construction, and some of the manufacturing considerations is determined by an API standard called API 19G3, which talks about some of the manufacturing considerations as well as engineering design considerations for the latches. What you see in front of you is a 1-inch latch for a 1-inch valve. There are few design features of these latches. It locks the valve in place. It provides the running and pulling profile, and it ensures that the valve will remain in place throughout the life cycle of the well until intervention tool will come and pull it. There are different type of latches for different type of applications. What you see over here, which is called a PK2 type latch, is one of the most common ones, and which is used for the 1-inch valves, and the RK type latch is used for the 1.5-inch valves. But we can have different design variations in the latches to cater for different type of locking profiles in the mandrels. The gas lift valves are usually, there are 3 types of gas lift valves, or 3 basic constructions of gas lift valves. There are dummy valves, which are essentially plug valves. There are unloading valves, which we are going to talk about in coming slides. They are used in unloading phase of the well only, but they are not used in the production phase of the well. And then there are orifice valves or operating valves, which are primarily used in the operating phase of the well. There are some specialty valves available as well. There are water flood valves, there are circulating valves, which will be outside the scope of this presentation. There are chemical injection valves as well. But to just give you guys a takeaway that we can do multiple different things with the gas lift system. It's just gas lift. It can be used for water flood applications. It can be used for chemical injection in the well, multiple different things. Dummy valves, as I mentioned earlier, are just plug valves. These are deployed in the well until we have a need for unloading the well or producing the well. Some of the offshore applications will use dummy valves in the gas lift until the formation pressure drops to a point where they need artificial intervention or artificial lifting. Then in that case, the intervention tool will go downhole and it will remove these valves from the gas lift mandrels, and then it will either deploy the unloading valve or the operating valve. Injection pressure operated valves are primarily unloading valves. These are, so talking about the injection pressure operated valves, this is a simplistic construction of a spring operated gas lift valve or a loading valve or unloading valve. There is a stem, there is a tip. What actually happens is that the gas will come over here. It will act on this surface over here, which is directly below a bellow and a spring assembly. It will act on this. This spring is set to a certain pressure, So it will not move until the pressure on this surface is to a point where it will overcome the spring constant. When it will overcome the spring constant, this whole stem tip assembly will move. When it will move, the gas will come. It will find the path of least resistance, which is this opening over here, and it will go inside the tubing. So this type of valve will normally stay closed, and it will only operate once the pressure differential is above the set point of the spring. Some of the formulas, so your question might come, what is the opening pressure or what is the opening force at which the valve will operate? The opening force is, if I go back to our famous pressure is equal to force by area equation, we will just dissect that equation, and the opening force is usually pressure that the valve will see acting on the surface of the spring or bellows. Spring or bellows are two different mechanisms that can be used in the unloading valve. So essentially, this pressure acting on this surface area minus.
Hassaan, there's a kind of a basic question that some students want answered. I think they arrived late. What kind of gas are you talking about? Like flames or just bubble gas?
Just a natural gas, which you see, methane.
It's just like air.
No, it's not air. So we cannot use air in the gas lift system. That's actually a very good question. You cannot use air in the gas lift system, primarily because in air we have, there are different things. Number one, if you use normal air, it has a high oxygen content. And in the presence of a spark downhole, it can actually catch fire. The other thing is that the normal air has a lot of moisture content, which we don't want downhole. One of the things that is very abundantly available in oil and gas fields is natural gas. So we try to use natural gas because it is available for the gas lift injection. So when we talk about the pressure over here, this is the pressure of the natural gas. So your methane. Methane is usually your most abundantly, or when we talk about the injection gas, that is the primary component of the injection.
What is the molecular structure of butane?
Methane. It's CH4.
Oh, CH4.
Carbon and
CH4.
Yeah, CH4. Yeah. So there are some fields that may also use nitrogen, but those are very, very, very specialized fields. Primarily, it's just methane that is used, or natural gas that is used. That natural gas that comes into your that is used for the for the gas lifting. So the opening force is essentially pressure on your bellows and pressure on this surface area. When the valve is open for it to close, the closing force is essentially this pressure PC2 multiplied by the area of the valve. So one thing which I want the students to take away over here is that this valve is normally closed, and it will not open until the pressure differential is able to overcome either the spring force or either the pressure in the valve. Until then, it will remain closed, and this is what we want. Operating valves or the orifice valves. These are called orifice valves as well. In some operations or in some areas or in some geographies, you will hear the word operating valve. Some people call it orifice valve. Essentially, it is a valve which is always open. So it will have an opening that is always open, and it will allow the gas as long as there is a positive differential across the gas lift valve. We control the injection of gas by replacing, there is a small component in that valve which is called a choke. So by changing the choke sizes, you can control the gas lift injection. And this is an example. I think it would be better to explain it like this way. So this is that orifice that I was talking about, or a choke that I was talking about. This is always open. So unlike what you saw in the injection pressure operated valve or the unloading valve, where there is a stem, there is a seat, and it moves. This one does not have any movement, at least not in the body of the valve. It will have this choke, and as you start changing your choke sizes, you can actually control the injection of the gas. This is what we call a square edge orifice. There are other advanced designs as well, which, for example, in this case, a venturi type of orifice as well. This is called Nova. And this is just a better design used primarily in the offshore. This square edge orifice is primarily used in the onshore applications. There is a check valve at the bottom. So you want the gas to flow one way. So the gas will come, it will inject over here, it will go through the square orifice and pass this back check. So it will push this back check down and into the tubing. Now this back check is over there to prevent that gas from coming back in and going into the annulus. We don't want that. We want it to be a one-way flow. This back check has a lot of considerations when we talk about the deep water and subsea applications. This back check essentially acts like a well barrier device. So it is actually tested to zero leakage. That means zero bubble leakage. This back check is since as I mentioned earlier, this is a barrier rated device. So it is a safety critical component. Because we don't want this back check to leak at all, because the leakage of it will mean that the tubing fluid will come, bypass it, and will go into the annulus. Sometimes this production fluid is very corrosive. It has a high H2S content. If it will leak past this back check, what will happen is it will go inside the annulus and it will start corroding your casing, and we absolutely don't want that. Talking a little bit about Nova, which is used in the offshore and subsea applications. This is relatively not a newer design, but a newest design, and it replaces the square edge orifice. It was the geometry of this venturi was designed after a lot of research and development. I will not try to go into that research and development, but essentially this profile reduces the pressure losses that happen in the Gaslift valve or in the square edge orifice, and it just gives you a better injection point and injection rates. One of the things that happen in the primary difference in terms of performance between a square edge orifice and the Nova is that you can have more precise gas injection. You have less pressure losses in the Gaslift valve. That means you can actually optimize your production, and you can actually use a Nova type operating valve at deeper point in the valve, because you can just control the pressure better in that case. Valve materials, as we start talking about deep water and subsea applications, you are talking about typically we don't use stainless steel and Monal grades. We try to use Inconel 918 or Inconel 718. These are nickel alloys, non-magnetic, and they are used for the sour service with the high temperature and high pressure applications. These are usually very expensive and are only required when there is a need for it. In terms of elastomers, we have different type of elastomers that can be used. These elastomers primarily act like sealing devices, and the choice of elastomers is based primarily on the downhole temperatures and the pressures as well. So your low grade elastomers like nitrile and neoprene will be used for the standard service, little to no H2S, while your premium elastomers are used for high temperature, high pressure applications. Similar is the case with the O-rings that are used in the construction of the gas valve. Monitoring and control. With the advent of gas lift systems, there is a lot of emphasis on the downhole monitoring and control, just to optimize production. As I mentioned earlier, that one of the flexibility about the gas lift system is that without use of rig, you can just use a slickline unit or a wireline unit to pull the valve. So you can actually optimize your production. You can actually use different type of orifice valves. You can optimize your production. And if you, as the well starts depleting, you can actually start using different choke settings, and you can ensure that you will still get a relatively stable production. So in terms of monitoring, there are a lot of things that we monitor in a offshore oil and gas wells. We are monitoring the gas injection pressure rates. We are monitoring tubing pressures, as well as we are measuring that the fluid that we are producing, how much of it is water, how much of it is gas. The more technical terms are water cuts and oil cut. And then we are also measuring the choke positions. What you see in the Gaslift valves right now is a fixed choke, but there are Gaslift valves with variable choke settings as well. We are not going to go into it because that is a more advanced topic. And then in terms of downhole monitoring, we are constantly monitoring our production. We are running different type of models and calculations, and we are trying to see how we can take the production to the next level. In terms of downhole sensors and what type of things or what type of sensors and downhole telemetry that is available, there are different type of pressure and temperature gauges that can be deployed as part of either the gas lift system itself or just above or below the gas lift system. One of the things is what we call cable to surface gauge. It's a pressure gauge that is deployed in the pocket of the gas lift mandrel, replacing gas lift valve, and it stays over there, and it is actually a pressure monitoring device with the cable running from the gauge to the surface, and it will give you pressure at that injection point at any time. It gives you a continuous, accurate, and real-time measurement. And then we have something which is called a distributed temperature sensor. It is a fiber optic cable that is deployed all the way from the surface to the downhole. And this fiber optic cable will measure temperature across the gradient or the length of the well. Usually what we are trying to see is that the point where gas lift is or gas lift injection is happening, you will see a big drop in the temperature. And DTS sensor is just helping us to monitor that. And then similarly, there can be different type of tools that can be deployed through the gas lift systems, and they can help us in determining production. These can be E-line tools or wireline tools, or they can be stickline tools. With that, I have got to the end of the presentation. I think we have some time to take some questions. So I would open the floor for any questions that may come.
All right. Okay, so yeah, we do have some questions. Let's start here with Ibtasam. What kind of metal are these accessories made from?
Very good question. Our typical onshore or gas lift system can be made from the carbon steel. So your 4130 and your 4140 steel grades. The offshore applications, they can be made from nickel alloys or stainless steel.
All right. Also, can we use liquid instead of methane?
You cannot use liquid because what you are trying to do is that if I go back to the principle of the gas lift is primarily based on the principle that once your gas is injected into your fluid, your density of that mixture will change. When the density of that mixture will change, essentially with all that gas being injected and mixed with the fluid, it will take the fluid to the surface. If you are just injecting fluid, you are not changing anything. You will not lift anything. There is another concept which is called water flood. In water flood, what actually happens is that you inject fluid. It has nothing to do with gas lift systems, but I can see the chain of thought or why this question actually came along. In the water flood, you pump fluid into the well, and that fluid, just because oil is going to come to the top of the water, with all that water being injected, it will push the oil to the surface. And then in that case, you can have.
Is there any need to recycle that methane gas?
it is usually recycled most of the time.
Okay. Let's go to Ismail with a question.
Morning, sir.
Hello, hello.
Yeah, good morning. Good morning, the presenter. Good morning, everyone. Yeah, my question is this. What are the challenges associated with deploying and maintaining gas lift systems in subsea environments? And how do environmental factors such as temperature and pressure impact the performance of gas lift systems in subsea applications?
Very good question. So gas lift is usually considered one of the most reliable methods of artificial lift. But obviously there are some constraints to it. You need to have gas. If you don't have gas on location, and if you don't have enough gas on location, you cannot do artificial. There are some challenges or some of the pros and cons of this system as well. Number one is that specifically for the subsea and deep sea application, one of the constraints is that we do not have the cost of intervention is just too high. It's very expensive to change the valves. It's very expensive to move the rig. So one of the challenge is that when you are designing a subsea well, you have to think about gas lift from the very start of the planning or very start of the project. It cannot come later in the project. The reason for that is that one of the things that you need for gas lift is a gas compressor. So you need to have a gas compressor or a space for gas compressor in your offshore platform. And the people who have actually worked on the offshore platform can tell you one thing, that the space is premium in our offshore platform. So if you deployed an offshore platform without a gas compressor and all the other equipment that is required on the surface for the gas lift system, and you deployed it, and later in the age of or the life cycle of the well, you decide to deploy gas lift, you are going to face a lot of challenge because you do not have space for the gas compressor. That is one of the biggest constraints which I see in. So early planning is very important, especially for the offshore field.
Thanks.
Thank you so much. Let's go to Stelio Sumbane. Go ahead and there you go.
Hello, good afternoon, everyone.
Good afternoon.
Okay. Yeah, my question is, if we want to start the design of the gas lift, how we know at that place we can find the gas, and which depth we will find the gas. And another question is, which material we can use to do the gas tank, the stock of gas. Yes.
Sorry, I didn't get the second part of your question. Which materials are used for what?
The gas tank. I think you can follow the gas tank. Yeah, which material you use to construct the gas tank? Yes.
Okay. All right. So regarding the material of the gas tank, it needs to be suitable to the production fluid. So if your production fluid has a lot of CO2 or H2S, then you need to consider metallurgies in stainless steel or better. But if there is a lot of water, very less oil, then you can actually settle with the carbon steel. Sorry, what was the first question?
The first question is, if you want to do the design of the gas system, okay, how we know that place we can find the gas and which depth? Yeah.
Very good question. So usually gas lift is deployed in the phase of well completion, which is called completing the well. Before completion, there are other stages as well. So usually it will start with the drilling of the well. After drilling, there will be if we need to frack the well, we will frack the well. And after fracking, we will do the completion. Before completion and between fracking and drilling, there is another phase which is called well testing. In well testing, what actually happens is that well testing crew will come and they will have different type of well testing equipment. They will have separators, they will have different tanks, they will have meters, flow meters. And what they actually do is that they will let the well flow under certain choke setting for a certain period of time. What they are trying to do is they are trying to determine that how much gas is there, how much oil is there, what are the pressures. So the results from that well testing report will tell you whether you can use, whether you have enough gas in that well for the gas.
Okay, okay, thank you. Sorry, I can do one more question? Sorry.
Sure.
Yeah, and I would like to know how we can define the size of the valves, of the valve, yeah. How we can define is a 1 inch or 2 inch? How we can decide that? How we
Very
can,
good
yeah,
question. Very good
yeah, yeah.
question. So the size of the valve is determined on many factors. One of the factors that we need to consider is the size of the tubing and the size of the casing. If I show you over here, this is the tubing and this is the casing. And if you see, the valve is on the side. And there is not a lot of space left between this valve and the casing. So one of the considerations is definitely space available for the valve. That is one consideration. The other one is how much you are injecting. The bigger the size is, the more you can inject. The more you can inject, the more you can produce, right? So now that also depends upon what is your production target. Now there is sometimes when especially in the well testing phase, you will realize that the well has a certain potential. It cannot produce more than that. So when you are designing your gas lift system, you would know that there is no point in deploying an 1.5 inch valve. 1 inch valve is more than sufficient because it will get to your production target. So that is the second consideration.
Okay, thank you, thank you.
All right.
Okay, thank you.
Let's go to Olufemi. Go ahead and activate your microphone. Olufemi, Oluleye.
Thank you very much.
There you go.
Professor Hassaan A, thank you very much. Please, this operation, is it limited to just one well, or can you use this one well to service the field? Because in this offshore environment, it may not be easy to be moving the offshore rig about. So my first question is, this operation that you have just described, is it just limited to one well, or can it be applied to other wells in the field? That's number one. Then second question, how do we maintain the pressure? I mean, how do we maintain pressure during this operation to prevent the fluids, high pressure fluids, from erupting into the wellbore and disrupt the operation? Then thirdly, my third question is, are we talking of just one phase or two phase fluid, or if we have three phase fluid? I mean, if we have the solids with the gas and also with liquid oil in the wellbore. So how do we handle the multi-phase fluid to ensure that we still have a successful operation? Thank you very much.
Thank you. So the first question about is it a single well, is it a multi-well? So usually typical gas lift systems are for single wells, right? So you will have in a field, you will have wells, and the ones which are suitable for artificial lift, you will have these gas lift systems deployed in that well, servicing that well exclusively. There have been installations where there have been multilaterals. That means you will have a single bore, and then you will have multiple bores. Gas lifting in those wells is very challenging, and there are not a lot of wells like that. 95% of the wells are completed like this way for the gas lift. Secondly, about the well integrity or uncontrolled exposure of the well fluids into the surface. So the back check in the gas lift valve that I talked about is a barrier rated component for the deep sea and offshore applications. Is tested to API and Statoil standards to ensure that it will not let a communication happen between tubing and to the surface. While this is the responsibility of the gas lift valve, but the rest of prevention of the exposure of the wellbore fluids to the surface is primarily your wellhead job. Wellhead would be the component that will prevent any uncontrolled exposure of the hydrocarbons into them. What was your second question about?
Okay, second question about the pressure maintenance. How do we ensure constant supply of the gas for this for the lifting of the fluids?
So the constant supply of gas is primarily dependent on your surface facilities. You need to have ample, a big enough gas separator to ensure that the gas is clean before it is injected back into the gas compressor. In your well testing, you will determine how much gas is available. And then based on that, you will have to see if that gas is enough to operate your gas lift system. Yeah, so your surface facilities have to be sized, have to be designed, keeping in view that you will have to do gas lift either continuously or intermittently. Sometimes what happens is that if there is not enough gas available, then rather than doing continuous gas lifting, we actually go to the intermittent gas lifting.
And my third question, in case of multi-phase fluids that are flowing, where we have some influx of sand, and then we have gas in the wellbore, we also have liquid from the hydrocarbon, I mean from the oil. So how do we maintain the pressure in the system to ensure adequate deep pressure differential to keep the bottom hole pressures away from the wellbore, so that we don't have a situation of an eruption of high pressure into the wellbore?
Okay, so if I understand correctly, one of the things, I'm trying to just understand your question. Usually, your gas lift systems are sized in a way with the selection of metallurgy, with the selection of appropriate valves, that they will. Essentially, what I'm trying to say is that, would you be able to repeat your question? I'm sorry, I'm trying to formulate my response, but I'm not really sure what your question is.
Okay, sir. Maybe let me put it simply this way. If we have a multi-phase fluid, I mean, we have solids due to sand influx, and we have both the gas and the oil in the system. So So how do we now manage this to prevent the formation pressure from erupting into the wellbore?
Okay, so solids have nothing to do with the wellbore pressure. Absolutely nothing to do with the wellbore pressure. But solid have something to do with the gas lift system. So one of the advantages of the gas lift systems is that they are very tolerant, or they are very flexible in terms of solid production. Solid production is actually a big problem in artificial lift systems, because solids can actually damage the other means of artificial lift systems. For example, your progressive cavity pumps, your electrical submersible pumps, your rod pumps. When there is a lot of solid, and by solids, I will probably categorize sand production in the solid formation, in solid as well. There could be debris, there could be paraffins, there can be scale, all of those things, good things that can actually affect our wellbore or a production of oil and gas. One of the things about artificial lift systems and gas lift systems, primarily gas lift systems, is that they're very tolerant to the debris production. That means if you see over here, the gas that is injected through the annulus is usually very clean gas. It has gone through a separator, it's very clean. It will pass through the gas lift valve and it will mix with the fluid. If there is any solid production over here, or if there is any solid over here, it will move as the part of the production stream and it will go to the surface, right? And when it goes to the surface, it will go through the gas separator, where if there is any solid, it will just go at the bottom of the gas separator, and then you can actually drain it out. So whenever we are doing the well testing and we determine that the sort of solid production is too high, that actually makes gas lift as one of the primary contenders of the artificial lift system rather than a secondary one, just because other methods of artificial lift are not very good in terms of solids handling. Especially ESPs are very terrible in terms of solid handling. Progressive cavity pumps are slightly better, but gas lift systems are one of the best for solid handling. But solid handling does not have anything to do with the wellbore production or the wellbore integrity or formation integrity or formation production. They are just one of the byproducts which needs to be handled on the surface.
Okay. Let's go to Jima Musa. Go ahead and activate your microphone. We can't hear you yet. You have to activate your microphone first. There you go.
Good evening, Hassan.
We can hear you now.
Lampard. Okay. I have only one question. Because now we have a type of gas lift, two types of gas lift. My question in the second one, the intermittent. What is the use of it? The use of gas intermittent. The second one.
Yeah, so sorry, what is the question?
Were you able to hear the question?
My question, yeah, we have a two types of two types of gas lift. My question in the second one, the second one, intermittent.
Yes.
What is the use of it?
What is the use for it?
The use. Yeah.
Okay. So intermittent gas lift is primarily used when you do not have enough. It is used in the mature fields or wells which are towards the end of their life cycle. What happens is that as the well starts depleting, it does not have enough fluid to push to the surface continuously. So there is no point in using continuous gas lifting, because the gas will come. If there is no fluid, there is nothing to lift, right? So, but these valves have the tendency to build up fluid over the period of time. So it will take from few minutes to few hours to build up the fluid in the tubing until it actually hits the lowest or the deepest valve in the gas lift system. So the purpose of this is that it will build that, so that the formation itself, formation pressure will build the fluid level to a certain point. When it goes to a certain point, the valve will open and it will push the fluid to the surface. That is the sole purpose of the intermittent gas lift.
What kind of tool did they use? It is the metal or the plastic tools? What kind of tools?
What kind of tools?
Yeah,
Which tools are you talking about?
because I'm seeing on the picture, it's like the metal or the plastics pipe, the tools.
Sorry, I didn't catch your question.
Because the surface controllers close it.
Yeah.
Those over here, and also we have the separator infection gas, and also the valve close it, and also we have here operating valve close, because it is a part for them. It's a part.
Okay, so if I understand your question correctly, you are trying to find what tools are used on the surface?
Yes.
I'm not aware of any specialized tools that are used on the surface, not related to the gas lift system. The thing which I would think on top of my head primarily is probably blinding tools or blinding flanges that they would use. There are no specialized tools that are required for the gas lift system on the surface.
Okay. It's fine. Okay.
Are you ready for the next question?
Yes.
Okay, we'll go to Aspa.
Okay,
Aspa?
good evening. How are you?
Hey, good evening.
Hello. Good
Hope you're doing well too.
I'm good. Okay, my question is about the excess amount of methane, avoiding or emission of the methane. Maybe it is from laboratory or from the environment, which is produced by the combination of hydrogen and carbon, CH4. So how we emit or avoid from the environment, because it is affecting the environment, as our educator, Dr. Hassaan, mentioned before. What the emission process, how we imitate from emission from the environment.
So in terms of emission to the environment, it's not primarily related to the gas lift system. I think gas lift, in a lot of other locations, gas used to be one of the nuisance to deal with. So they used to flare out the gas. But what actually happens now, or what they are, especially with the gas lift system, you can continuously recycle the gas. Regarding the emission into the environment, it has not much to do with the gas lift system itself. It has more to do with the wellheads and, you know, all the fugitive emissions that come from oil and gas site. That's a very entirely different topic, and I may not be the right person to answer that.
All right. Do you have another question?
No, I am.
All right.
No, I don't have any.
Thank you for the question, Asfa.
All right, thank you.
Okay, now we go to Ibtisam. This might be our last question, considering the
Yeah.
time.
Hello, everyone.
Hello, hello.
Hello, Dr. Edward. How are you?
Doing good.
All that time. I want to ask, we can use the butane instead of the methane? The first question.
Butane instead of
Methane.
methane.
Yes.
If the butane is in the gaseous phase, yes, you can use it if it is available as well.
We can use it. Why? It has the same low number of carbon.
So yes, you can use butane if it is available on site. Yes. You can use nitrogen, you can use methane, you can use a mixture of the gases as well.
And a second question: what should be the temperature of gas when we use this accessories?
So the temperature we try to have the accessories are actually, or the gas lift system is actually rated to, including the seals. A normal system can be rated to 200 to 250 degrees Celsius.
Okay.
But yeah, that is the normal temperature.
Okay, these accessories that you let's show, we use it in the industry when we separate or purificate the contents of petrol in the sea. Yes.
No, that is a separate system that is called three-phase separators. They are different from a gas system.
We use these accessories when we have to collect the gas in the sea, especially the methane.
Sorry, is there a question there?
We use these accessories that we that show in the industry when we collect. We have to collect the gas in the sea, like the methane or butane.
You can use this for production of gas as well. Yes.
Yes. Okay. Because we can use all these accessories in any type of another type of industry.
Not that I'm aware of. It is primarily used in oil and gas production.
Okay. Thank you. Thank you.
Thank you for the question, Ibtisam. I'll just have a quick question. When an oil field is all depleted, do they leave those do they leave the tubing in the ground, or do they pull that up?
No, so at the end of the life cycle of the well, there is something which is called abandonment, plug-in abandonment. And what actually happens is that the responsible companies, they will pull all this completion out. They will cement the hole, and they will do all the remedial work on the surface so that it goes back to its original condition.
Okay. And just a question, this all looks very expensive. Why is oil relatively cheap compared to all of this expensive machinery and high expensive drilling? Why isn't oil more expensive?
Why oil is not more expensive? Just because of the volume. Some of these fields, some of these offshore wells are producing 20,000 barrels per day. With 20,000 barrels per day, with the cost of barrel in today's US dollars, you can actually have a very small ROI, even with a very significant capital expenditure.
Because I remember you saying something about changing out the valves was a very expensive process, but considering the volume of the oil, wouldn't changing out the valves actually be kind of like not expensive?
So the changing of the valve does not happen very frequently. It is done on case-to-case basis, or maybe once in 1 or 2 years. Because the depletion of the well, usually offshore well, does not happen in a very short period of time. It will happen over the period of years. And as it starts happening over the period of years, then maybe after a year or two, they will do an intervention, they will remove the valves, they will install new valves. And considering that it is producing 20,000 barrels per day, sometimes more than that, then the cost justifies the investment.
Okay. Do you have time for one more question from Abdoulaye?
Sure.
Okay. Let's go to Abdoulaye, who hasn't asked a question yet. Abdoulaye. Can you activate your microphone? Let's try that again. Abdoulaye. Are you able to activate your microphone? We see you there, I think. Okay. We can hear you,
Hello.
but it's not clear. Go ahead. What is your question?
Are you hearing me?
Yes, we can.
Hello.
Go ahead with your question. We can hear you.
Yeah. Thank you for that. I would like to know what is the link between if this gas lift operation is used in operation for I can say for making the exploitation of the oil. Is there link between this kind of machine and the machine people which the engineers use for making the exploitation of the oil? Thank you.
Sorry, Prof, did you catch the question?
No, I did not. I was wondering if so can you repeat the question? Please repeat.
Okay. Are you understanding my questions?
Yeah, go ahead and repeat the question.
Yeah, I say if so I would like to just ask a simple questions. How the engineering were used for making the machine, making the machine which exploit the oil. Is there difference between the farm? What is the feature is? What is the feature is? What is the features of the machine? Who people or the engineering are using for the making exploitation of oil and the gas, also the gas, oil, and other resources into the land.
So you are trying to, if I understand correctly, you are trying to understand what is the future of this technology going forward? So just to recap what we discussed about. Okay, so right now there are a lot of things that are happening, especially with related to the gas lift. There are different type of smart systems that are coming in. As I mentioned earlier, that we have to change the valve whenever we have to change the venturi size or the orifice size. Now there are projects in place where we are developing valves with smart venturi. That means it will change when it will get a signal from the surface. So it will change its diameter. So there would be no need for an intervention going on. So smart gas lift systems are thing of talk now these days. Similarly, different type of sensors that can be integrated into the gas lift systems. So we don't have to run them separately. Those are other things. Integrating the gauge mandrels with the gas lift mandrels. That is one more thing that is happening. So yeah, there are a few exciting things coming down the road.
All right. I think that's going to There. I think that's going to be enough for the class. There's one more question from Samuel in chat. How do nitrogen charged valves work? But that could be a long answer.
So I will try to give a concise answer to that. So the nitrogen charged valves, if you see over here, this is one of the nitrogen charged valves. Essentially, there is a dome at the top, and this is a dome where the nitrogen is going to be compressed and stored, and then it will be injected through that dome into the bellows. The bellows effectively acts like a spring, just like a spring-operated valve. They are set. The pressure of nitrogen is set in a way that the bellows will only move when the certain pressure differential is actually applied across the valve. Nitrogen charged valves are very common, and they are considered more stable and more reliable compared to spring activated valves.
All right. I think that's going to do it. Thank you so much, Hassaan A. What will you talk about the next time you come back?
I am going to talk about subsea systems.
Okay. Excellent. Okay, I think that'll do it for everybody. You can now activate your microphones. So to say thank you and bye. Everybody have a wonderful weekend.
Bye.
Thank you.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye.
Thank you very much.
Good
Yes,
presentation.
Hassaan A.
You are welcome.
Bye.
Professor
Thank you, doctor.
Thank
With
you.
that
you,
being said,
Professor.
I'm grateful to you, sir.
Thank you for your
Thank you very
questions.
much.
Thank
Really.
you.
Thank you.
Thank you.
Bye.
Bye.
Good to see everybody.
Have a good weekend, everybody.
Thank you.
Bye.
Thank you.
Have a good weekend until we meet again.
Thank you very much.
Yes.
Everyone.
Bye, Sammy.
May you all be
Thank you.
drilling
Bye
for
bye.
oil.
Thank you,
And
Sammy.
Well,
by
Bye.
Monday, you'll have a lot of oil coming out of the ground.
Wait, I don't.
Get to work.
let's drill oil. We have a big lake.
We must finish on graduation now.
Thank you.
Thank you so much.
Dr. Lambat,
Thank
Yes,
you.
yes.
we must meet on graduation day now.
When is graduation day?
Next year.
Yeah. Well, no, isn't it November or something?
I received the email that the graduation is soon. We must book it.
Hello.
I don't know. You
My
probably know
goodness.
more than I do.
Yeah, I think it's November or the early next year.
I just know it's like the first week or two in November. And then the
14th
next
of
one's going to be
November.
next March or something. I don't know.
How many
14th of
credits you
November.
must have in order for you to qualify for graduation?
It depends on the program that you have. Like a bachelor's, you need 120. In the master's, you need 30. And in the doctorate, you need 50.
Oh no, I'm doing bachelor, so I need 120. But
Yes.
I think now I'm above 95.
Yeah, just keep doing your assignments, writing your essays. I'm going to be sending out an email tomorrow on how to do SMART goals. It'll be a little video showing like how to plan your assignments so you can get them done on time.
Yeah, by end January, I will be down on 120.
Yeah. Yeah, 120 credits. It shows all that knowledge you're going to be building. So see, if you need 25 more credits, that's what? Divided by 3, that's 9 courses. And that's a lot of studying.
Next year we're graduating. So we're graduating online or we come to USA?
If you look at the graduations in February or March or April, they're online, they're virtual. But it's in October and November, those graduations are in person.
Yeah,
as far as I know, that might change next year. I don't know.
So, I want those where you travel.
Yeah. Yeah, some of us weren't able to travel to our graduations. I was one of them. So I missed my graduation in person.
Hey,
Not everybody can travel.
Traveling.
Yeah.
Bye, traveling in November.
Enjoy our weekend.
And remember that you can graduate in any month. On the 10th day of every month, we make that list of graduates. So if you have everything complete by the 10th, you can be on that graduation list. Otherwise, you have to wait another month to be on the 10th day of the next month. So just so you know, you can kind of plan which day, and then once you can kind of plan which month you want to graduate. And then once you're on that graduation list, we start processing and legalizing all the documents for your graduation. And then we mail those to you to an address that you give. So if you go to the in-person graduation, the paper you receive is not the actual diploma. Everybody receives their diploma through the mail.
Okay.
Yeah.
No, we will push, Doc. We'll push so that we graduate on face-to-face.
Yeah.
Yes,
So
ma'am.
I think that's going to be in November. So you probably have what, 3 more months to get if you want to graduate in face-to-face this November, you have 3 more months to finish up your program.
That's a lot of time.
Yeah. Yeah. Yeah, because nowadays you don't need a lot of time to study courses because the internet makes studying so fast.
Yes.
Yeah. Like in the past, you'd have to walk to the library, find your book, read through your book, sit down at a table. Nowadays, you can watch videos really fast. You can get all the books summarized online. You can search quickly through a digital book for the things you want to find. It's just so much faster now.
Yes, AI is advancing to the right direction. Everything is in your smartphone or laptop. You can study wherever you are, even in the bus, in the train, or in your room.
Yeah, you really don't need textbooks anymore when you have like ChatGPT. You can just say, teach me about accounting or teach me about international relations. And then if it'll give you some information and then say, I have a question about that term. Can you explain that term a little more? And it's just like talking directly with a teacher. It's amazing. And anything you want to learn. I was doing some statistical analysis with a student on their research project. So I said, okay, let's go to ChatGPT. I want to show you what ChatGPT can do. So I put in some of their data and I said, analyze this data with a statistical analysis. So it chose the statistical analysis and brought back all the p-values and the test statistics and everything and wrote up a little discussion of it. It was perfect. And then I said, can you put that into a graph form? And then it came out and produced this nice graph with red and green and yellow and different colors. And it was perfect. And it explained the graph. It was like amazing. The ChatGPT actually produced all the things you need to put into a research paper from your research, which gives you the possibility now just say, okay, what do I want to research? Go out and get the information, feed that information into artificial intelligence, and it'll just write out your paper and your research paper for you. Then you go through, make some edits, put some things you want to put in there. It makes it so easy now. In the past, when you do a research project and you have to do statistical analysis, maybe you have to find someone to talk to and you give them the information and they spend a couple of weeks putting it together and then they give you that and then you have to write it up and it takes, maybe a month or two. Now it will just take a day. Less than a day.
In the olden days, you were supposed to read a lot of articles for literature review and journals, and then you summarize, you reference by hand. But now you can also reference with your ChatGPT or any software.
Exactly. So if you want to research a particular topic, if you go to ChatGPT, it'll tell you what a lot of people are thinking. But if you go to one journal article, it tells you what that one person is thinking.
Yes, that's a good part of it.
ChatGPT will say, okay, this is what the state of the art knowledge is. And it's much better to get that kind of broad vision from ChatGPT, because it's bringing in together a lot of different articles into its answer. So it's actually a much better answer instead of having to read like individual articles. So to
Can
get
I
the
ask?
knowledge that you need is so much faster now.
Yeah, sorry, Doc. Can I ask you some question?
Sure.
If you want to do MBA with AIU, will they give you? Is it possible for them to give you 100% scholarship, or they will give you a partial scholarship?
I don't know. I don't work with the scholarships, so I do not know how they do that. I don't understand how the scholarships work, because I just focus on the courses and the things you have to study and how to present your knowledge and how to grow your knowledge. So the scholarships and tuitions and all that, I don't work with that at all.
Oh, okay, okay. I don't know. I have to ask someone
But
who's assisting
let me tell
me
you
with my
this, for an MBA, normally when you look around the top schools like in Stanford University and places, I really like Stanford MBA program. It's kind of the model that I work off of. And for a master's degree, they would want you to focus in on developing a business plan. And that was like the basic project that you would have to do to get your MBA is to do a business plan. Write it up. How do you write up a business plan? How do you do the financials and the marketing and the executive summary? How do you do the structure of the company? How do you create that vision? How do you put it all together, and how do you do a business plan? The thing nowadays is you can get a business idea, go to ChatGPT and say, okay, start writing up a business plan for this idea. And then it'll give you back some information and you say, okay, here's some information about the marketing I've done. Can you include this in the business plan? And it'll come back and edit its information and write it up for you again. And with ChatGPT, you can write up a business plan within hours if you have all the information ready to go. All you need to do nowadays is understand the information that it is producing for you. And what's going to happen now is all you really need to do is you have to be the person to take that business plan and go start your business.
Yeah, here in South Africa, I got the offer at the University of Cape Town for MBA.
Yeah.
For 1 year, but I'm still waiting for bursary offers. But I think it's very vital if you do
MBA
with
is designed to
international
produce
varsity.
entrepreneurs, people who will go out and analyze businesses, find out where the business opportunities are, develop a business plan, and start businesses. That's what an MBA is really designed to do. Create entrepreneurs. So you have to do your business valuation course. We have one of those. We have a good book that talks about business valuations. And then you have to be able to know how to identify where the business opportunities are. And then once you start that business, you have to understand how you're going to make a profit. You know, what kind of staffing do you need? What kind of buildings? How much rent do you have to pay? How much marketing do you need to do? And then once you start visualizing the business, then you put together that business plan. And that business plan is your ticket to funding, loans, and starting the business. And that's really what an MBA is all about.
Yeah. Would you encourage a student to do MBA if he or she is having the opportunity to study PhD, then another opportunity is MBA? Which one will you advise to start with?
Well, you have to have a master's before you have a doctorate. So you have to go through the master's program.
No, me in my country, I do have masters. So I got this offer for MBA and then another offer for PhD. So
it depends what you're going to do in your PhD program, what kind of research you're going to do, and what you're going to produce as far as usually in a
Yeah.
doctorate program, you're going to get very specialized in what you study.
Yeah, me, I want to specialize with public health on my PhD, and then later I can do MBA.
Well, if you already have a master's, then you can do the doctorate, and then you can come back and do another master's, but you can't get a doctorate until you have a master's, unless they work differently there.
No, I do have masters in South Africa.
Okay.
Yes.
So then, yeah, once you do the doctorate, you'll have that specialized research. And when you do a doctorate, it should not be the same major as your master's. For example, yesterday there was a student doing educational management. And the student did the master's in educational management, and now they were doing a doctor's degree in educational management again. And I said, no, that doctor's degree needs to be more specific. It needs to show more focus and a higher level of learning. And I looked at her courses and I said, no, this is actually community development of education. So because she was doing she was looking to look like working with the United Nations and other international organizations to do educational development in Madagascar, for example, where she lives. She's from Ghana, but she lives in Madagascar now. So I said, no, change your major to community development of education. And then once you go to those international organizations like the United Nations, they look at your master's and go, okay, community development, that's the words they want to hear. Educational management, what does that mean? That's okay, you want to manage a school somewhere. But if you want to do community development, that's a whole broader, greater vision of how to develop education. Because she was thinking about working with the 2030 goals of the United Nations. So I said, no, change your major, and that'll get you a better ticket into those people who work with the United Nations. So these are just little things that when you develop that doctorate degree, the name of your major is really important. You want to make it really stand out as something different and unique. But that's gonna talk to the people where you want to work.
Okay. So after your PhD, Doc, for you, in order for you to qualify for being a professor, how many articles or journals you need to write?
Just keep writing. Just keep publishing. Don't stop.
Okay.
Just set yourself goals of like every year I'm going to publish 3 research papers, for example. Or you're going to say maybe I'll do a research paper every 2 months. And then after 2 years, you'll have 24. Is that right? Am I counting that right? No. 12.
Yes.
You'll have 12 research papers. You do 6 a year. And think about that. If you have 12 research papers, then you have a blog and you're posting them on there, and you're maybe talking in some conferences. You're on the other side. It's like there's no, if you say, okay, all I need is 3. Well, there's some people out there who have 10, and you go for a job and I have 3. This other person has 10. The more you have, the better. There's no, just keep going. Just keep going. You want to be the one with 100 research papers out there, right? And that's what we want. We want to teach you how to do ChatGPT. Work with ChatGPT on how to do a research project, and then it'll help you do the statistical analysis, the discussion of it. It'll help you write up the conclusions, but you'll want to put your own words into that final conclusion on what it means for your community, what it means for your culture, what it means for your country, right? But so ChatGPT kind of gives you the bones of the format of how to write these up with really good formatting. But you're going to want to go in there and give it your own spirit, your own cultural heritage, your own family values, everything from you that you want to make this speak for you, not just from ChatGPT. So it makes it so easy nowadays to do statistics. And you can just start off and say, I want to research the best way to build a railroad system through South Africa, right? And these are the problems that we are having in the railroad system in South Africa. So what research would be a great research to do? And it'll come back and tell you and say, well, maybe you want to study the geography, or you want to study how the demographics are changing in South Africa. Okay, I think it would be interesting to study the demographics of how demographics are changing in South Africa. What do you know about that? And then ChatGPT will come back and give you some information and say, well, then you go off and read something else, and you come back and say, well, I learned this. Now tell me how I can research it. Oh, well, this is what you want to do. You want to study this particular region, see how the demographics, it'll take you through that whole process of focusing in on where you want to do your research. And then you'll ask, can you set up a research methodology for me to do this research? And it'll come back and say, okay, what you want to do is you want to do some questionnaires, and these are the questions you want to ask, and this is how we'll do the statistical analysis. It'll set up the whole research project for you. You just have to print off the questionnaires, go out and get the answers, give it back to ChatGPT. It'll do the analysis for you, write up your papers, you're done. It's just, the world is changing so fast that you have this powerful tool to do exactly what you need to do to open up your career opportunities.
Thank you so much, Prof. I think, studying nowadays is quite very simple and interesting.
Yeah. So yeah, ChatGPT for how much it costs is really very cheap. It's like oil. Why is oil so cheap? It's because of the volume of oil they produce. Why is ChatGPT cheap, comparatively? It's the volume of knowledge it makes available to you so quickly and easily. That its value is so much greater than its cost. But you just have to use it and learn how to use it. So yeah.
Thank you so much, Prof. Thank you so much about vital information. I will invite Ismail in Africa.
There you go.
Mr. Debula.
Yes. How are you?
I will invite you in South Africa.
There's no problem. I will surely come.
Yeah, I will show you Kruger National Park. I will show you Table Mountain, Robben Island. There are so a lot of places, tourist attraction here.
Thank you for this. I love this opportunity.
Yeah.
And Ismail, you could go to artificial intelligence and say, I live here in this part of my country, and these are the things that we produce in this part of my country where I live. Can you help me start an export business? And just start asking questions to ChatGPT and say, what do I need to do to set up an export business? Where would my market be? Where do you think I could sell these products to other places in the world? And who could I contact to set up distribution to those other countries? And you just have to go to ChatGPT. And then also you could just go to, like yesterday with the student from Madagascar who wanted to get in touch with the United Nations. So I was saying, why don't you contact the United Nations? And she says, I don't know how to contact them. So I went to google.com and I said, United Nations in Madagascar. No, United Nations office in Madagascar. And the first search came up, showed the office. So I clicked on the link, and there were all the names and all the email addresses that she needed to contact people of the United Nations in Madagascar. So within 5 seconds, she had 12 contacts, 12 emails and 12 names of people she could contact in Madagascar to start setting up her project for education. It's just that fast.
Oh, thank you, sir.
Yeah. So
I'll try this, sir.
And if you want to do grants and international funding, and you want to set up a business with Bokangai in South Africa, You guys get together and say, you know, one of you lives in one country and one of you lives in another country, and say, how can we set up a export-import business between our two countries? Right? And then just start working up the specifics of how to do that.
Yes, I think I will visit North Africa very time soon, but I'm not good in French, so I will only speak English.
Says what?
No,
You're saying what?
Bokang. No, Bokang.
I really want to visit North Africa, but I'm not fluent in French. French language.
Okay.
No, there are translators online. You write in whatever language you want, and it automatically translates it to French. That's how I speak with our French students.
Okay.
And that's how they speak with me. Sometimes they'll translate their French into English and then write that into an email. And then I'll send them back translating their English into French so they can hear my French. I just go to translate.google.com and you can translate any language into any other language. You can do business in French, Arabic, German, Spanish. You can do business in any language if you have translators.
Are you coming from?
Huh? What?
Mr. Elias Kayuni. Which country are you coming from?
Well, Samuel. Yeah, I'm from Malawi. For your information, I was also in South Africa for 6 years in Durban.
Yes.
Yes, and I used to import vehicles from Japan. I used to hire drivers from Malawi, and part of drivers, I would get them from South Africa, bring the vehicles to Malawi.
Yeah, did you see how busy the harbor it is in Durban? The harbor in Durban is very, very busy.
Yes, it is. It is. I worked so hard, and also now the law in South Africa changed that we can't drive through any longer. We have to use the carrier to drop the vehicles at the border. And then from there, we have to drive from Messina now to our countries. So if I knew you before, I was going to contact you.
No, it's never too late.
Thank God for AIU. Now we can have some kind of conversations. Yes. Sure. Where are you based in South Africa?
We are networking, we share business ideas.
Yes. Where are you based in South Africa?
I'm based I'm in Eastern Cape sometimes, but next week I will be in Bloemfontein, Free State, and then third week I will be in Cape Town, so I'm traveling.
Okay. I know at least Eastern Cape, yeah. I've traveled a bit there. Sure.
Okay.
Do you two know how to contact each other?
Yeah, maybe.
Yeah, I think we can talk via emails. Then after emails,
can you send your email
on WhatsApp.
Yeah. Exchange emails.
What about on this our chat here?
Yeah, in chat you can exchange
put email
emails
there
and keep in touch and say, look for business opportunities. So Bokang, you're like, there's a product here that people are making. Do you think it would sell well in Malawi?
Yes.
And then say, can I send you some, and you go ahead and distribute it throughout Malawi, and you can both make money.
Oh yeah.
And then you say, okay, there's another product here. What do you think? Yeah, let's try it out. Send me a few samples, and I'll send it to my distributors. You know, start setting up a network of businesses. And you don't need to just have one job, one business in your life, right? I have a brother who has 800 businesses.
Wow.
He has 800 different businesses. And many of his businesses are just web pages that he bought. He would buy like the URL of a web page and then do advertising on that web page. That's a business. because it's just a little web page. He buys another web
good
page. That's
evening,
another
Dr.
little
Lambert.
business. There was a
Good evening, Dr. Lambert.
in the United States, you have tort law, right? There's a certain type of tort law. So he bought the web page tortlaw.com, right? So if anybody's going to do a search for tort law on Google, he pops to the top. And so they're going to click on his link. And every time they click on his link to read about tort law, there are all these lawyers advertising on the side of the page. And he receives income from those lawyers every time somebody clicks on his link.
Good evening, Dr. Lambert.
If you have tort law in South Africa, create a page called Tort Law South Africa. And so every time somebody searches for tort law in South Africa, they go to your page, you get some advertisers, you get money every time somebody visits your page.
Good morning, Dr. Lambert.
Hello, Promise.
Yeah, good morning, sir.
Good morning and good afternoon to you.
Yeah, good afternoon. Please, sir, can we create a WhatsApp group for us, we the students, so that we can, any information, we can drop it there?
Yeah, we're actually trying to set up a group in the platform, so that the students can come to the group and start sharing ideas.
Yes,
we're working on it, and the programmers are working through some of the technical details of that.
Okay, thank you.
But a good way to do it is during these meetings, when you see somebody that you really feel you can work with, get their email, keep in touch with them. And let's say Bokong and Samuel and Ismail, so let's say they begin to develop some products shipping between each of their countries, and then you come in from another country and say, hey, can you send some of your products here? I'll sell them here. So everybody starts making more money when there's more countries, more people working in different countries selling those products.
Okay, sir.
So get their emails and stay in touch with everybody and start developing side businesses. Even if you study political science, usually you're going to have to get a job in an office somewhere, but you can also have side businesses where you're doing export, import, tutoring, online things like that. Like the lady from Madagascar that I talked with yesterday, she has a school, but she also teaches online to people around the world making money, and she needs to raise her income. So she has income from the school and income from online working. So as you can see, you've got to just keep looking for business opportunities and keep developing different business ideas, and each one will add some money. Like in my brother's case, he may make like a few dollars off of one of his web pages. Hey, but that's a few dollars. And if you have 100 of those making a few dollars, by the end of the month, you have a lot of dollars. Because each page, if you have 100 times 5, that's $500. And because each one's making just a little bit of money, but when you have a lot of them, we're talking volume again, like the oil that comes through that tubing we saw today in the gas lift systems. When you start looking at volume, you just need a lot of little things, and that's the volume. Each one's producing just a little bit, but it all adds up. I think Samuel, you did something like that too, because you were creating like different areas of your business, right?
Yes. Well, for me, some of them I was just trying there, which one works around. I started with cars, one vehicle, and then later on, I ended up even in a bit of construction and also holding sand. I don't know if that means if somebody's building the house, needs materials, I'll send my truck to, they'll hire my trucks to do that. And also I used to import vehicles from Japan to Malawi, and then I find out that there are so many people now importing vehicles from, because that time it was very difficult. I had access to internet. So because I had access to internet, people used to come to me and I would pay for their vehicles. So I used to make money off that. And later on, I changed to import, instead of importing from Japan, I start flying to UK. And then I also had these now I have townhouses where I'm building small houses, 3-bedroom houses where people are renting, and I get something from there. And well, that's what I can say a bit.
Like
So
in my case, when I lived down in Chile in South America, I worked in 2 universities. I worked in a high school. I worked in another institute with private learning. I was also doing acupuncture. I was also selling food that I would make at night. And then during the mornings, I would sell them to people going to school. So I had 6 little businesses, and that's how I was able to like live. So a lot of times you just have to find any opportunity you can and work it into your schedule. You get busy, but that's good, right?
Fred Gokran, the gentleman from South Africa. My first car I bought when I was at school in Durban. I used to cut grass in the gardens of people. And periodically also, I used to cook in the homes of people during the weekend. Then I bought a car, my first car from school in South Africa.
From high school?
No, yeah, at the college.
Okay, okay, the college. Okay, okay.
Yes.
Yeah, you were the good entrepreneur for a while.
I'm trying.
Yeah. And here,
Yes.
even when I was, even a few years ago, I was working as, managing the academics here at the university. I had a second job where during the day I would take care of elderly people who needed help. So I would wake up really early in the morning, do some of my work for the university, then go take care of those elderly people. And then I would come back and finish up my work at night. And then my daughter started to do homeschooling. So then I had to teach her 4 hours a day, go off and help the elderly for another 4 hours a day, and then put in another 9 to 12 hours at the university. And we're talking, 18-hour days, but got a lot done.
Oh yeah.
So
you are so hard worker, bro.
Ishmael, what do you think?
Yes, it's right. It's very good. I learned a lot.
Well,
Well,
yeah.
I used to think that whenever I moved to a new town, I would take any job available. Anything. Just to get into I would do construction. Like when I would do like demolition. And it was like the lowest paid construction worker. You just go in there with a sledgehammer and you just destroy the building and then, take it all away in wheelbarrows and put it into a truck and then take it away. It was just hard work. And that's how I started off in construction too.
And
yeah, there was, mornings when you wake up and everything is frozen. The ground is just frozen, but you have to dig a ditch to put in some piping. So you're waiting for the sun to come up to melt the ice on the surface of the earth so you can dig, so you can get that shovel. Otherwise, it's just like hitting ice.
Wow.
And so I was working with some men from Mexico, and they too, they just, get whatever job you can. And I remember the man looking up at the sun and saying in Spanish, La cobija de los pobres. The blanket of the poor was the sun. And so it's like, you just do what you can, work where you can, just stay busy and build up.
You know, Prof, when I joined
It's
AIU in
interesting.
April,
Wow.
I learned a lot of skills in terms of multitasking, because within 3 months I had skills to scrutinize my time.
Yes.
So maybe when I'm in Cape Town, that side I'm doing medical male circumcision
Ooh.
on the people who need help. And then when I'm in Free State, I'm busy doing public health and occupational health. But when I'm in Eastern Cape, I'm busy with rehabilitation of mental ill prisoners and all the mental health care within South Africa. So I think, yeah, getting a lot of information at AIU gave me some strength and powers to do multitasking. I love multitasking, but I didn't have necessary skills how to manage my time.
Yeah, you sound very busy because you're traveling at the same time, so you have to figure in your travel time.
Yes.
Wow.
Sometimes I usually prefer to take flights to minimize some time.
Well, do you want to start like a side business with export import?
Yes, I can do. If it brings me some extra income,
Yeah,
I jump in.
absolutely.
Yes.
Ismail, what country do you live in?
Egypt. I'm in Egypt. Yes.
Ishmael, hey, you've got a lot of work to do, my brother. Here, I'm having 440 clients. I'm having one guy from Egypt. He doesn't have relatives in South Africa. So he's been in my institution since 2015 till today. They don't have, the client doesn't have the relatives. He's saying he's River from Egypt. How did he came to South Africa? We don't know, but we took him from the correctional service department. Then we rehabilitated him. Then now he's stable, but we can't get his family.
Wow.
Hmm.
So you mean he's from Egypt or is an Egyptian? He's an Egyptian.
He's an Egyptian. Yes, he's an Egyptian, because now you see he's stable, but the bed he's occupying for these years, how many people we would rehabilitate if he was discharged home? Then he get the care treatment and rehabilitation services in his country or nearby his relatives.
I'm a Nigerian anyway. I'm a Nigerian, but I
Oh,
live.
oh no, I thought you are from Egypt. Yeah,
No,
I thought
I'm
you
in
are
Nigeria, but I live in Egypt.
Okay.
Yeah.
But hey, he's having a lot of stories, that guy. Some personal I don't believe, because when you look on his face now, you cannot say he's an Egyptian, but you cannot judge. You cannot judge. If he's telling you I'm an Egyptian, even if there is no passport, we thrived by tracking people on social networks, social media, Twitter, X, Facebook, Instagram. Hey, this guy, no one knows him.
This is why.
Okay, everybody, I want to share my screen with you and show you something.
Okay.
I'm here in ChatGPT and I asked the question, what is the best type of product to export to Egypt for a small business? Okay, exporting products to Egypt as a small business can be a lucrative venture, but it's important to consider the market demand, local preferences, and regulatory environment. Here are some best types. Food and beverages. That's the first thing that came to my mind, is that Egypt is going to have some food problems as the years go forward, and they need to find better ways to import food. So you have some specialty and organic foods that maybe in South Africa, you have some special foods that you can actually export to Egypt. Cosmetics and personal care products. You could even make soaps in your house and then just ship them off to Egypt to have somebody there. Ismail could go around and sell those soaps to different stores. Give them a nice, there's some great African soaps that we have here in my local store. And so you can send off some soaps and some shampoos and other skin products, fashion and apparel, electronics, household goods. Furniture might be a little bit big, but if you have something that you could send up there, health and wellness products, fitness equipment is always good. Children's products, toys, clothing, and books. Children's books is always a good one. So here's some ideas that you can go with right there. And so it gives you idea to look around to see what kind of skincare products are available where you live. And then just go, Ismail, here's some pictures of what we have here. Can you go around and see if anybody would like to buy this? Check out the market, do some market research. See how easy it is to get some ideas?
Yes, you got some idea and then you put them in action, and the business start operating.
Yeah. And I'm just going to take this, copy that, put it down here, and now change Egypt to Malawi. Now let's see if we get a different answer, right? Agricultural product. Now it's talking about seeds and fertilizers are more important. Food and beverages, of course. Clothing, textiles, footwear. It didn't mention that about in Egypt. It didn't mention footwear, but in Malawi, yes, footwear. Solar products, solar lamps charges, medical supplies and pharmaceuticals. Bokang, that might be something you have connections into, pharmaceuticals and medical supplies.
Yes, of course.
And books and stationery, educational tools. Yes, that's a big thing. Mobile phones and computer laptops. So yeah, there's products. So ChatGPT kind of knows what some of the market is in Malawi and is giving these recommendations. And Samuel, can you confirm or not confirm that these are the best products?
Let me confirm. Yes, those are the best products that we need in the country. We
Seeds
don't
and
have
fertilizer?
Yeah, for sure. Last year we even had a shortage of fertilizer in the country.
Wow.
So this is one of the best products that can be sold in Malawi. No question about that. And footwear, Egypt, they have the best. Very nice.
Footwear, yeah.
So then Ismail could export footwear to Malawi.
Yeah.
Yes, I will receive them.
There you go.
I can set up the shop for you. Not a problem. So we can both make money.
Yes, it's a good idea.
And Bokang, do you have medical supplies, bandages, gloves, antiseptics? Do you have things like that?
Yes, in South Africa, I think a lot of things
have
are available here. Even the fertilizers, because we have in different provinces with different crop, with different biomes. So a lot of things are here. Even the pharmaceutical things are here, especially in Durban. Hey, Durban is rich. Durban and Western Cape, Durban and Cape Town, yeah. A lot of things happen in those provinces, even Free State and Limpopo. You know Limpopo, Mr. Kayumi?
Yes, I know. Just before leaving South Africa, it's called Limpopo.
Yes, yeah. That province is also fertile with a lot of products. So if we can,
for your information, many of our products, normally we buy from there instead of traveling all the way to Johannesburg. So it's closer. Yeah.
Yes. And the sweetest banana is there in Durban. Banana is very cheap in Durban.
Oh, I didn't know that. Okay.
Okay, now let's look at South Africa. What products would you export to South
Bananas,
Africa?
best
Wolfgang, can you
bananas.
confirm these? Fashion and
Okay, okay,
apparel,
bro.
footwear, specialty foods, organic, gourmet and health foods, cosmetics, electronics, dietary supplements, fitness equipment, furniture, books and stationery, spare parts for autos. Samuel, did you
Yeah.
hear that?
Oh yeah.
Yeah.
Oh yes. It's
There's
my
probably a really good market for moving spare parts.
field.
Yeah.
Seat
Mm.
covers, floor mats, other accessories are popular in South Africa for
Mhm.
car accessories. Solar
We
products.
I
ahead.
import them through DHL from South Africa.
Yes.
They spare the parts for cars. I import them from South Africa through DHL.
Yes.
So if we
In
have
which province?
mostly it's in Johannesburg.
Okay. I saw in Cape Town they have a lot of uh, uh, the lot of scrapyard and the car repairs, also the parts.
And for your
Also in
information,
Gqeberha, it was Port Elizabeth.
yes,
Yeah, also
for your
also that, yes.
for your information, in the Cape Town, you have so many 4x4s vehicles.
Yes.
I think because of the geography of the place, so you need 4x4s. So mostly when it comes to 4x4s parts, I know they even if we import from Johannesburg, but many times they will say, okay, we are going to get it from Cape Town. So I don't have contact with anybody in Cape Town. Yeah. Yeah.
No, my brothers are staying there about around 3. When I'm in Cape Town, I don't rent because they settled a long time ago that side. So even one of my older brothers said, no, if you want the Toyota Fortune 2.8 liter,
Yeah,
the strong one,
that's
you
true.
must come to Cape Town. I said,
Yes.
why? He said, no, just come to Cape Town. I will show you. So he's been there since 2014.
Yes, they are reasonable. Yeah. Yeah.
Yes. I think also the
So
advantages of different harbors, because there is a harbor in Cape Town, there is a harbor in PE, there is a harbor in East London, also the harbor in Durban. So I think in terms of exporting and importing is quite very easy in South Africa because of those harbors.
I have your email and you have my email. Let's communicate and see what we can do. And yeah, not only you, but with the others. I think my opinion, God has put us together for a purpose. It's not only for education, but it's still education anyway.
Yes.
We have learned from each other. We are learning from
Thank
each
you
other.
so much.
Yeah,
Yes.
yeah, yeah.
Thank you
Sure.
so much. Thank you so much,
Thank you
Yes,
everyone.
so
thank you.
much.
You know,
Thank
You're
one
you,
thing,
everyone.
welcome.
sometimes like when you talk about fertilizers, it's hard to find like just nitrates or potassium. But what you can do is create compost. And if you have like a sector with a lot of animals and bananas, just have them ship their refuse to your operation where you're producing compost. And it's very cheap. You just have to move them in, water them down, aerate them a little bit, and then you're producing compost. And by the time it's like fermented for a period of time, it creates this beautiful compost for growing food.
Wow.
Just get some plastic bags, put a name on there, Bokong compost, right?
Yes,
Smiles
I'm
compost.
aware.
Yes.
And then
You
start shipping it off to other countries. Ship it to Malawi. And then people can start doing community gardens, growing food.
Yeah, you know, there is this place, Matli and Yogi Elliot, they are having big forests from PG Basin. So a lot of people there, they are renting for stock farming. Yeah, there everything is cheap because of the fertile soil. Even you don't spend a much in terms of fertilizers. You only spend in terms of feeding during dry season. Also dosing your animals. Otherwise, we create the fertilizers with the feces of the animals. Then and you get the fertile crops. So I think yeah, that place is very is having a very good soil.
Yeah,
If
here
because even the Pichu Basin, they are making a lot of products from that soil. I think the difference between down is 70 to 80 kilometers, but yeah, it's a very good soil, and they are
so
producing. They are making a lot of products.
here are the instructions on how to create compost. Just pick a location, gather materials. Actually, it doesn't mention here about like manure from horses and cows, but that's actually a really good source of nitrogen. So you could actually, and chickens, chicken feces builds a good compost. And then it talks about building it in layers, alternate the layers. Then you want to turn the pile every few weeks, monitor the moisture. If it's too dry, add water. If it's too wet, add more browns, check the temperature. And so once you learn this little system of creating compost, use the compost tips for success, smaller pieces. You know, you might get a chipper to create smaller pieces like the bananas. You don't want to just throw in a big banana stalk. You want to throw that banana stalk through a chipper, and it'll create like little bits of banana pieces.